Let's do it quickly.
Let's do it quickly. Yes.
Okay. Shall we start? Hello, everyone. Today we are going to talk about designing a logical network for ThingsEngine. This presentation will be presented by Chenjia Tian, Sid Seth, and Ranjit. Next page, please. This is our outline presentation outline. Next one, please. So for the business goal, we need to provide a scalable and security network so that they can design and order the IoT device from manufacturers all over the world, and an e-commerce website for the customers to browse all products of TE on their website, and customers should can order, buy products and pay through online from their website. And we need to provide a security connection with six warehouses. They are located in different places in Australia. And the automatic adjust of inventory information about the orders product in the warehouse database, and fulfills the large demand of the smart home IoT products all over Australia by developing a security network. And the tracking of door-to-door delivery man all over Australia who would help to set up to text the IoT orders products for the customers. And automatic delivery message to the customer's phone by texting them when the product is ready. And we need to provide high-speed bandwidth to the warehouse connector for stream videos about its products and other customer and other service information to the video screen at each local brand office. Next page, please. The cloud computing is not required since the managing director does not support a cloud-based solution, and all servers of TE will be hosted in the room in the main office. Next one, please. So there's our technical goals. The network should be scalable because they are willing to expanding their marketing due to the large demand of the smart home IoT products all over Australia. So it's necessary to ensure the scalability while designing the network, and the infrastructure must be available 24/7 to give the best experience for the both internal and external users. And availability is important to trace the product's inventory, manufacturer information, and taking orders from the client in real time. And the security is one of the most important and critical technical goals of designing their network. A highly secure network will protect the client, business, and financial information against breathing and data loss. And this network design will also consider the adaptability for adding new features and functions so that it can adapt and usable for the growing number of traffic and provide requests all over Australia. And to cut off latency, a high-speed bandwidth is required to achieve the perfect performance. High-speed internet will increase the performance of browsing websites, updating database, application, and service. So next page, please. Here's all of the trade offers. All of the technical goals will be scaled by total 100%, 100, and the security part and the availability part will be scaled higher than other parts because they are most important. So the next part will be presented by Sid. Seth, you are muting yourself. We can't hear you.
Yes, thank you, Chris, for reminding me that I was muted. Okay, so let's continue. As you can see, this slide is about the table of user communities, and the community name are as follows: managing director, finance manager, purchase manager, storekeeper, logistics managers, accounts, network manager, clients, and delivery man. And the number of users are mentioned here, and beside that, the location, which is mostly, as you can see, is in main office, which is in Brisbane, except client and delivery man. And the application used by the user community varies from users to users, as you can see here on the left side, on the right side. Okay, this slide is about the table of the data stores. As you can see, the data store names are as follows: web servers, email servers, database servers, video stream servers, FTP servers, DHCP servers, and DNS servers. And they all are situated in the main office, which is in Brisbane, and the applications and the users are actually varies applications to applications. For example, here, as you can see, the FTP servers can be accessed by the internal users, and the applications here is about the sharing files to high speed bandwidth using a secure password encrypted service, whereas the email servers can be accessed by internals and externals users only, and where all kind of emails related to the organizations can be accessed by them. In the next slide, which is about the table of network applications traffic characteristics. As you can see, the applications are on the left side, starting from enterprise database, websites, file server, DHCP server, DNS server, and video servers and syslog servers. And after that, the traffic types, protocol use ports, user community, data stores, bandwidth needed, and the quality of system is also given. And the following after that is the logical network design. As you can see here, the design is about the ThingsEngine, and as per the requirements, each warehouse requires a computer to store data of IoT products, and a video streamer to display the products. There are 6 systems which are connected to the main office for the usage of managing director, account manager, purchasing manager, finance manager, logistics manager, and storekeeper. And the routing starts with core layer level core layer 3 router to manage traffic service throughout the main office and the warehouse. And there is a firewall which has been created to filter data that can be that can be usable to end users as well. And this firewall will also secure organization data from threats, threats and blocks untrusted entries. And there is once the data is filtered in the main office, it will be shared to the warehouses via a virtual private network, which is known as VPN. And the encrypted IP package helps secure the transmission of data via public network with 2-factor authentications. And on the lower left-hand side, you can see there's a place named DMZ. This is the sub-network design to a DMZ switch. This is an isolated zone which protects the entire LAN connection from untrusted network traffic. And the next slide is about the addressing and the naming of the following of the previous network design, where you can see the PC configurations are the web server, database, stream server, network manager, purchasing manager, storekeeper, logistics manager, managing director, account manager, and financial managers. And after that, you can see that IP addresses and the prefixes are given. And after that, the subnet mask and the default gateway are also shown. And the next slide will be covered by my team member Razi. Thank you.
Yeah, thank you, Ahmad. Now we're going to talk about the routing and switching protocols. We already created logical network design for ThingsEngine organization. So first of all, I'm going to talk about the routing protocols. Under the routing protocol, there are if you see that network diagram, you can see the internal and external network. So for the internal network, I prefer two protocols, routing protocols, which are RIP version 2 and OSPF, which get some special features, special things. So that's why I choose these two. RIP version 2, which is use netscope details for communicate each routers. It send the netscope details for each routers for making the connection between each routers. And OSPF, it's a link state routing protocols, and it's communicate send the hello or package to each near the routing routers. So it's connect, then it make the connection between each routers. And also it's a link state routing protocols. Compared with the RIP version 2 protocols, the OSPF protocol has some more specific features, like it's consume less bandwidth. So I preferred OSPF protocols for the internal routing as an internal routing protocol. Then I'm going to talk about the external routing protocol. When I talk about the external routing protocol, I prefer BGP protocol, which can use for the external routing protocol, because it has another name is the internet protocol, and it's select the shortest path this selector is a distance vector protocol, so it select the shortest path as the best path of the route when calculating the route. Then we are going to talk about the switching protocols. Can you go to the next page? Yeah. Uh, Under the switching protocols, I prefer the spanning tree protocol, which is used for the switching protocol. It's because it's prevent the loop in the network, uh, by creating the extra route between the switches. So most popular spanning tree protocols is IEEE 802.1D in present. And we have some more spanning tree protocols also, such as IEEE 802.2, IEEE 802.5, such as. Then we are going to talk about we are going to discussing about the security mechanism. Under the security mechanism, we're going to talk about the physical security mechanism, authentication, authorization, accounting, data encryptions, and firewalls. Under the physical security mechanism, it's, it's a very important, it's a primary security mechanism which is preventing damage of equipments of data by installing proper security protocols. And identification security mechanism is a process of identifying and verifying users before accessing to the network. And under the authorization protocol security mechanism, each users will be given only specific access to the resources based depending on their jobs. So like a scorekeeper can have specific resources to access, and other roles has specific features, specific roles access to resources. So then we are going to talk about the accounting security mechanism, which is help which is help an organization to avoid future incidents. Then we are going to talk about the data encryptions security mechanism. Under the data encryption is another security process which protects data from third party for unknown party. So then we are going to talk about the firewalls. Firewall security mechanism which applies security protocols between multi-network to protect and filter data. Can you go to the next page? So now we're going, as a conclusion for this network design, we first of all, we read the case study and we find some business and technical calls, and then we list the constraints of business and trade-off, and then we created tables for user data stores, communities, and applications traffic characteristics. Then we develop the network design, and then we discuss about the protocols, routing and switching, and discuss about the security mechanism. Can you go to the next page? That's our end of the presentation, and these are our reference. Thank you so much.